Okay, well, thank you very much, and welcome everybody to this session on execution plans. Now, I have presented in Italy and Spain in the past with a real-time interpreter, and in both cases, they came running up to me after the first session to tell me I was talking too quickly because you needed a little extra time to say something in Italian compared to how fast you can say it in English. So I will be trying to avoid getting excited, but if I do start talking quickly, do please interrupt and tell me to slow down a little bit. Okay, since we're on a webinar of this type, I thought it would be possible simply to run up scripts in SQL, display screens from an SQL plus session, rather than relying on something like a PowerPoint projection to use large type, because I'm hoping that all of you are sitting in front of ordinary PCs with ordinary type screens and can see a decent number of lines of text without any trouble. So I can do things which I wouldn't be able to do if I were in a public arena and there was an audience sitting 30 feet, 10 meters away from me and a huge screen behind my back. So I'm running Oracle 19.11. I'm just running from SQL Plus, and I'm going to go through a few points about execution plans and reading execution plans. Now, the feature of execution plans is that there's a very simple, very well-known method for identifying what happened first and then working onwards from there to what happened next. And this method, unfortunately, is wrong. There's a very common statement along the lines of, you just keep going down and to the right, and when you can't go further to the right, that's what happens first. Well, that's only true in one very special set of circumstances. There's an alternative way of expressing this. It's one I've used quite frequently, which is first child first with recursive descent. If you look at one line of a plan, it's going to have some, usually no more than two, some child rows, some lines below, which are just indented slightly before you get to the next line, which is at the same indent. And the rule there is simply that a parent will call its child for data, and it will call the children in order down the plan. And again, whilst that's roughly the right sort of thing to think about, it's only true in certain circumstances. So let's look at a statement and start talking about the plan we get and things we have to be aware of. So I'm going to just call up a script here. I hope I can actually get my, yes, session started. A couple of points here, by the way, with this SQL plus script. You'll notice I've started up at the top with setting trim spool off, setting tabs off, and then setting line size and page size. If you ever want to post an execution plan or something of that sort to an online forum or an online mail list, you really need to work a little hard at making it easy for other people to read. So trimming off space at the end of lines, changing any tab marks to use spaces so that tabulated data comes out evenly spaced, uniformly spaced is a good starting point. Picking a decent line width so that someone doesn't say, well, my plan had lines which were 186 characters wide, but I've just left myself the default 80 character width space, so every line wraps around 3 lines, bad news. So do think a little bit, if you're going to post a plan up, make sure it's readable to the people who are going to see it. Okay, so let's look at the query which I've got here. I picked up the emp and dept tables from the old Scott schema. There's still a demo sample SQL somewhere in the Oracle Home admin, which will generate these. I've got here a query which starts off saying, I'm just selecting from emp. I've got a few columns here. I'm selecting from emp, but one of the columns in my select list is a scalar subquery. I'm saying work out the average salary for all the employees in the same department. Little point here about presentation and ease of readability and maintainability. Emp appears twice. So the first time I've given it an alias, E1, and here I've given it an alias, E2. Whenever you have a table, give it a short, convenient alias. Usually I stick an alias at 3 letters, which look like a reminder, a clue about the name of the table. If you use the table more than once, stick a number on the end of it, that alias to count through. And use the correct alias for every column you reference in your entire query. So here you can see my correlation between the subquery and the main query is that the E2 emp2 depth number equals the E1 depth number. Makes it easy to avoid mistakes. Okay, so I've got my scalar subquery in line, and then I've got a predicate in my where clause which says the E1 salary is greater than, and then I've got another subquery. The average salary from emp again, so I've called it E3, where the department number matches up. So I've got some details which are just show me about each employee who earns more than the average for their department. I'll just quit here for a moment and run this statement. We can see 3 departments have been reported. There are actually 4 in the depth table, and we've got, let's see, 6 employees who match the requirement out of the total 14 which are in the table itself. So let's go back in and do the first little check of what does the execution plan look like. So I've just set up auto trace. Jeff mentioned that a moment ago. I've switched auto trace on and run again, and there's my execution plan. A couple of bits and pieces to look out for. Emp appears here, here, and here. We've got 3 occurrences of emp. Which one is which? We've lost the information about which emp came from which bit of my query. That's bad news. Interestingly, we've got 2 brand new objects in our plan, something called VW SSQ2 and something called VW SQ1. That's just part of Oracle doing clever transformations to deal with our query. Our subquery seems to have disappeared. We've got a hash group by, which is aggregating some stuff, another hash group by, which is aggregating some stuff, but we can't immediately see something which says, compare this column with this subquery. It's just disappeared in the way Oracle has transformed our query. So if we've got something like this, where new things appear, old things disappear, duplicates seem to be present and we can't decide which is which, we can actually call up a lot more information from the execution plan. So let's go back and pick up just a few more details. Rather than using auto trace, I'm going to pick this option, explain plan. And a bit further down, I'm then going to say, select from table DBMSX plan, display, and with the formatting command, show me aliases. This is one of the very convenient things, which it would be nice if Oracle made it the default display. So let's see what we get when we ask for aliases with our execution plan. Here we go. We have this section called the query block name object alias. And we can see straight away that we now have emp. We've got an E3, which somehow is associated at cell $3. We've got an E1, which was at cell $1. And we've got an E2, which is at cell $2. That's our aliases. We've had a better explanation. We've got a little more information about the emp as it keeps reappearing. If you look here on the left, we've also got this thing called a query block name. Strange 8-character hex type of object, cell $, then an 8-digit number. This 8, 9, and 10, these 3 rows here, represent a query block, which is about that part of the execution plan. We've got 3 rows here, 4, 5, 6, represent this part of the execution plan. the important detail that comes out from this is that when you hear this rule about keep going down and right or first child first, this is a rule that applies to each query block. And what I'm looking at with this query is a query which is turned into something with 3 different query blocks. I started out, in fact, with query blocks called cell$1, cell$2, and cell$3. That's the default names that Oracle decided to give my query blocks. And I've ended up with 3 query blocks. There's this thing here, cell$683B0107, this thing here, and then the final query block is a bit scattered. It starts up here at operation 1. It carries on down here at operation 7. In fact, if we go up a little bit, the 2 lines here, the hash join outer and hash join, are also part of that query block, but Oracle hasn't repeated the query block name. So we have 3 query blocks. And the simple basic rule, which you've probably heard of before, applies to each query block separately, because a query block is the thing that Oracle optimizes. And once it's optimized query blocks, it then says, how can I connect these query blocks together to produce the overall execution plan? So when you're trying to interpret an execution plan, the first thing you really need to do is say, can I recognize the query blocks? Because if you don't check the query blocks, you might try to force the wrong pattern into the plan and find yourself trying to explain something which is actually the overlap of a couple of different query blocks, and you're reading it as if it were a single query block. So query blocks are terribly, terribly important. Okay, so having got the query blocks there, we can look back a little bit and say, well, what's going on here with the different query blocks, and can I do better than simply run up these query blocks? Well, let's switch on to a different text I've got here. And in this text, oh, is this the right one? Oh, I beg your pardon. No, I don't want to do that just yet. I'm going to go back here to my original query. That cell$1, cell$2 is really not 100% helpful. But if we can see query blocks, we can give them names. And every time in your query, you can see the word select or insert or update or delete or merge. That's the start of a query block. You can give it a name. So let's give our query here a few query block names. There's a hint, QB name. Let's call our opening thing main, QB name main. We've got this scalar subquery in line. So let's give that a name. Let's call that QB name scalar. And down the bottom here, this where clause subquery, let's call that subq. Right, so what does that do to our execution plan when we do the same call for the query block outline information? Here we go. Oops, I've obviously made a slight mistake. Let me just go back and correct that. I've left the plus off here. Now, when we run up our execution plan, you can see here that E1, line 7, was emp from main, E2 came from the scalar subquery, and E3 came from the where clause subquery. So here's another important point when you're running SQL. Not only should you give every table an alias and use the aliases for every column, you should give every query block a name which is nice and easy for you to identify, so that when you start looking at complicated things, you can actually check back very easily which table in the plan came from which query block in the original query itself. So we've got 3 query blocks there, which are now named as easily as possible so that we can pick up what we want to do. Okay, so let's start playing around just a little bit with what we've got. So far, I've got explain plan and select star from table dbmsxplan.display. One thing about explain plan and auto trace, because it's really just the same thing hidden behind the scenes slightly, is that it can lie to you. So I'm just going to add in a little extra. I'm going to run the query. I'm not going to call dbmsxplan.display. I'm going to call dbmsxplan.display cursor. Now, in that form, it will give you the execution plan for the last query that you ran. Now, this is specifically an SQL Plus thing, and one of the traps to watch out for is this, up near the top of my file here. Before you do this from SQL Plus, you must set server output off. Otherwise, actually, let me just demonstrate what happens otherwise. I'll let server output stay on. I'm going to try and use the show me the plan for the last thing I executed, but I got server output on. And Oracle says, find a plan for the last thing you executed, right? That happens because server output is switched on. So let's switch it off. And do the job properly. Now, what have we got here? On this occasion, I made a call to show statistics, and for some reason, Oracle has decided not to. And the reason is because I forgot to put in the hint, which makes it happen. If you can add this to your code when you're testing, the hint gather plan statistics, there's also an option which is the statistics level. If you set that to all, that will also switch on these same statistics. Not only can we see the plan, we can see how much work was done by each line of the plan. I'm just going to shrink that down slightly because it's gone off screen. So here's our plan again. There's the tables we're interested in. And then we've got here a wonderful column, which is the number of starts. How many times did each line of the plan start? We've got our estimated rows. That's from explain plan. It would match that. But here's the actual number of rows that went through the execution plan. The time spent on each line, but that time, by the way, is the time on the line plus all its child rows. Okay, so you have to be a little wary of exactly what it means to say the time spent on the line. The buffer visits, again, it's a cumulative figure, and memory usage. Okay, so we can get some statistics about how much work was done in each line of the plan, and necessarily, as a consequence, of course, we can see where's the best place to approach solving a performance problem with this plan. What's the worst bit of the performance? Where's the work going? Where is the time going? Okay, so let's take yet another little viewpoint. I want to bring in, let's see, at this point, I think I want to add in the format option to say, not only have we got all these bits and pieces of detail so far, we can add further information here, which tells us more about the plan, because we might want to do something to change the plan. I'm going to put in what would be stored as an SQL Plan Baseline to reproduce the plan, or what would be used as the stored outline if you're still way back on a much older version of Oracle. So let's take a look at this execution plan when we look at its outline as well. It's just another section of the plan that appears. And here we are. This is the outline of the plan. Basically, it's a set of hints. It's a set of hints which, in theory, will reproduce the execution plan completely. And so, for example, here we can see a hint which says unnest and it's using the query block names to point this command, this hint, at a particular query block. So unnest the thing I've called scalar. That was my inline thing. Somewhere here I've got another unnest, I think. Yes, here's unnest the thing I've called subq. We noticed hash group by all over the place. Well, here we go. Here's a line which says use hash aggregation. Do a hash aggregate rather than a sort aggregate. So we can play around with this thing. If we think we have a bad execution plan, we may decide that there's a certain feature which is actually the problem. And if we look at the outline of the plan, we might then say, oh, yes, right, okay, I can see where some of my problems are. Let me change this execution plan. Let me pick up some of these hints which I've got here and say to Oracle, say, well, just don't do that. I don't like what you've done here. So let's pick up this one here. No, let's see. Let's pick up this. Let us say to Oracle, do not unnest the scalar subquery. And let's see what happens when we say to Oracle, don't unnest the scalar subquery. So in here, no unnest. Okay, reverse it. Don't unnest at scalar. You really have to be quite careful when you type these in, because otherwise you type it wrong and Oracle says, yeah, that's not a proper hint. I'm ignoring that. So let's tell it we don't want it to unnest scalar and watch the plan change. Our plan here. Okay, I've just had a message flashing up that my internet's unstable. Are you hearing me okay? Anyone?
Hi, Jonathan.
Yeah.
Maybe sometimes it cuts a little bit. I don't know if you want to try to turn off your camera, maybe to have best performances.
Yeah, that's what I shall do. That's where are we? Video settings. No, how do we do this? Video, just switch off the video. Okay, oh, the video has not switched off.
Yeah, I think it's okay on our side.
Right. Oh, I see. My video is showing me a picture of me, but yes. Okay, that may help. Good. Okay.
Thank you.
So hide that. So now, yeah. So there's our plan after I've said do not unnest. And notice here now, we've got a query which says, well, we've got this sort aggregate up here near the top of the plan, and we've got two emps down the bottom. That thing which was VWSSQ_2 has disappeared. Right? And when we look further down here, we'll see that we no longer have something which says unnest scalar. In fact, we don't have a no unnest of scalar. We just unnest subq. Okay, let's push things a little bit further. Let's say take that use hash aggregation, because maybe that's just using far too much memory, and we know we can do better. Let's copy that and put that in here. Do not use hash aggregation. And while we're at it, I'm going to take out the all stats and last, because I'm not too worried about those. I will say, show me the outline and show me the aliases again. Because at this point, it's quite nice to see these things. There's our outline now. It's become shorter and shorter. In fact, I'm going to go one more thing. I'm also going to say, don't unnest at subq. Just don't do any silly things whatsoever. Very, very simple outline now. Oh, and here's our plan itself. We now have the sort aggregate at the top. We have a filter, full table scan of emp, and then a sort aggregate of emp again. And when we look down the bottom here in the query block and aliases, you can see I've still got 3 query blocks. I've got the scalar query block, that's lines 1 and 2. I've got the main query block, which is now reporting lines 1, 3, 4's sort of gone missing, and 5. And I've got another query block, which is a sub-queue query block, which is lines 6 and 7. So we've actually got 3 query blocks in this query, and we've got them stacked. So here's one feature of reading execution plans and that problem of first child first, or keep moving to the right, and that's what happens first. I've got a scalar subquery in my select list. If you put scalar subqueries in your select list, you may find that Oracle tries to unnest them and just turn them into a join with a hash aggregate, a hash group by. Or if Oracle doesn't do that, all the scalar subqueries in the select list will end up stacked on top of the main execution plan. So this thing up here, it's just an inline scalar subquery. It's the very first thing we hit as we read down the execution plan. So if we want to read this execution plan, one of the things we might do, if we've got a copy of it, is simply to say, well, we'll just ignore that bit for the moment. Forget that bit, right? Our main query is, actually, it's a sort order of a filtered emp. That's our main query. We do a full table scan of emp, and we filter out some of the data. What do we filter out? Well, actually, we've got a query block here. This is our subquery, which is doing our filtering. But we can look at this subquery, complete subquery, and say, can we see the predicates that we get for that particular subquery? What is it? How does it work? And once we've worked out how that subquery is working, we can say, right, a filter with a subquery says filter for each row that I get in my first child here. I'm going to execute this subquery, and the result I get from this subquery will tell me whether to keep or discard a row from the emp table. But we do need to look at this query and say, there are basically 3 different query blocks going on in this query, 3 different query blocks, and I ought to think about the 3 of them separately and then decide how to stitch together, how to connect those 3 different query blocks, okay? Each query block in turn, the whole thing of first child first, or the go down and to the right until you can't go any further to the right and then start working back, that guideline is a pretty good guideline for a single query block. But first, make sure you've isolated the query blocks and know how you're going to have to put them back together again. Well, about problems with execution plans when you do explain plan, or when you call up this business of running the query and then looking at the execution plan. So let's go back to the text. I'm going to show you, first of all, just display cursor all by itself. Yep, that's right. Okay, this is the plan where I've got all those don't unnest, don't do this, that, or the other. I have my filter subquery. I have a hand raised. Can we get something in the chat? Okay, if you look at line 4, filter, when I pull the plan from memory, line 4, that filter which says for each row in this full table scan, I'm going to run a subquery, looks like this in the predicate information. It says, I want the rows where the E1 sal is greater than, oops, I've forgotten what the subquery was. It does not report back the subquery. So sometimes, just to make sure that you're looking at the right thing and you understand what's going on in that execution plan, you probably do have to go back and say, I will do an explain plan. So what happens when we change to explain plan. Instead of doing a display cursor with exactly the same display requirements, we just do a straight explain plan. This time we can see it's the same plan, you'll note, but this time we can now see Oracle saying E1 is greater than, and look here, here's the subquery itself that is the thing I'm using to calculate my filtering. I'll just point out here, by the way, we've got depth no equals colon B1. Now, if you haven't actually written hasn't come up from PL SQL, it's a pretty good clue when you see a colon B1 or a colon B followed by a number that Oracle is using internally, so to speak, bind variables to act as correlation between one part of a query and another part of the query. So that's not really an end user bind variable, that's an Oracle internal bind variable saying, for each value I get from this part of the query, I feed it to that part of the query. It behaves like a bind variable. So sometimes you don't get quite what you need, even when you pull the plan direct from memory. Sometimes you've got to look at explain plan, display. But inevitably, nothing is ever perfect. So let's change to a simpler query. I'm going to gather stats on my emp table, and I'm going to gather stats and say, for all columns size 10, I'm going to gather a histogram on the depth no column in particular, because the number of employees per department varies. Then I'm going to set up a variable in SQL+, which is a numeric variable, and set that value to 10. And then I'm going to do something with this. Select star from emp where depth no equals that variable. Okay, now just before I do that, I've also run up this query to show you how many rows there are in the emp table for each of the different departments. Okay, so having done that bit, there'll be a brief pause, and then I've switched on this statistics collection, put in the hint as well, and said, now we'll actually run the query and we'll pull the plan from memory. And you'll see why I'm doing this in just a moment. So here we go. Actually, I think I will exit and come back in just in case there's a bit of garbage in memory before I run this one. Run. Okay, so each of the departments, department 10 has 3 rows in it. I run the query, the output. The key detail I want you to notice here is that Oracle says, my estimate of the row count is 5. All it's done is say, there are 3 departments, there's 14 rows, divide one number by the other, the answer's 5, nearly, right? Part of the reason it's done that is that when you use explain plan or auto trace from SQL+, Oracle says, I don't know what type of variable I'm looking at here. That colon B1, I will assume it's a character, which is why when you look down here, the predicate section says filter, depth no equals convert bind variable 1 to a number. But we know it's a number. Oracle doesn't. Now, when I run the plan and pull the plan, when I run the query and pull the plan from memory, here we go. Suddenly, Oracle says, my estimate of the number of rows is 3. It's got it right. Okay, why? Because there's on that column, and Oracle can actually see in the histogram that, and it's known about this bind variable B1, it's looked at the actual value of that bind variable, and that bind variable is numeric. So Oracle knows the right answer for its estimate. And when we look down here at the predicate, you can see the predicate has also changed. And it says depth no equals bind B1. There's no conversion to character going on. Oracle knows exactly what's happening. So explain plan, well, in this example, it just got the arithmetic wrong. Its estimate of rows was incorrect. But also I showed you that it's treating the bind variables in explain plan as if they are character strings. And that could say cause Oracle to not use a particular index. It will cause it to do the wrong arithmetic. Various things could go wrong. And when the numbers go wrong, and some slightly more subtle and complicated things can also go wrong, explain plan will end up telling you the wrong execution plan. It will lie. And even if the bind variable you're looking at is supposed to be a character bind variable, you can even find the explain plan lying to you, because explain plan says, oh, it's a character variable in the database character set. Oh, and when the query runs, it's a character variable coming in at the client character set, which is different. And I've done a character set conversion en route, and the arithmetic comes up differently, and I've disabled an index and all the rest of it. So you have to be very, very careful when you're trying to analyze queries with bind variables in. If you want to run them, rather than just saying, I'll sneak into the production system and pull them out of memory after someone else has run them on production, if you want to fake it on your test system, you have to be very, very careful that you don't do something a little bit wrong and end up looking at the wrong plan and trying to fix the thing that isn't really the problem. So explain plan is a little bit dangerous, right? You should be looking at running your queries in order to find out how they really execute queries from the application and pulling their plans with their actual values of bind variables from memory, so that you do actually see exactly what's really happening. Okay, so explain plan is a problem. Explain plan will lie to you. Okay, other things you can do, and I am aware actually at this point that I'm running out of time. You can get at trace files. You can get at the SQL monitor. You have to be licensed to do this. Let's look at the next little thing I've got here. We're going back to my heavily hinted plan here. I've switched on the SQL trace using the old-fashioned method of using it. And I set up here a trace file identifier. Okay, so you could actually run something from your own, and then I've switched off trace, and we can go and look at the execution plan in the trace file. Before I do that, I'll just come down here and point out, this is the new exciting way, I say new 11G way of enabling tracing. I've said here alter system to set the tracing event. This alter system set event says, I want SQL trace switched on, but I've actually restricted it to say only whenever you see. And an interesting detail of this is that if that's the SQL ID for a PL SQL procedure, what you get is the trace of all the statements that executed inside that procedure. But this is a very beneficial way of being able to trace a statement. You don't have to hope that someone will run it soon. You just switch it on at system level for a particular SQL ID and sit back and wait. So what I'm going to do now is just run that. And if I jump over here to the trace directory, there's the trace file. And then, of course, I can do something like this. Pick up the trace file, which I've tagged so it's easy to see. Do that. I'm going to do something just a little dangerous. Explain equals Here we go. There's my SQL statement. Down here, there's a little summary of the activity that took place. Down here is the execution plan. And the reason why I showed you that explain equals is that if you put in an execution plan, an explain equals request, that is just the same as saying explain plan. It might lie to you. If the execution plan was already dumped with its execution stats in the trace file, you'll see something headed row source operation. And this is just like doing this gather plan statistics, and the statistics level equals all. Okay, we can see the plan there. And also, we'll get some information about where the time went on waits, if that were the case. Now, I seem to have made a mistake with my explain equals, because unfortunately, Oracle isn't showing the other thing where it says, here's an execution plan. And by the way, this execution plan might be a lie. If you get plans from trace files, you want to make sure that you look at the one which says row source operation, because the alternative might not be true. Okay, now at that point, I really ought to stop because I've run up through my 45 minutes. We'll just have a few minutes left if people want to ask questions.
Yes, you have a few minutes if you want to close some argument, because I can't see questions on the chat. So if you have something that you want to add, there are no problem at the moment.
Okay, right. Well, in that case, I will pick up one more little detail, because obviously you can't always get at your trace file. It's nice to be able to do so, but you can't always get at the trace file. However, I have created a view as sys and made it available to public, and it's a view called My Trace File. And I think this could appear in Oracle 12.2. There is a thing called the $diag info, something of that sort. Let me show you this. I think I called it this. Okay, if you want to look at this in more detail, we have a web address here. That's a blog note I wrote about this only a couple of years ago. And we can query this view, $diag trace file contents. And you can specify the trace file name and the location of the trace file. There's some things you can look up. I've got variations in my blog, but I have created a view which says, find my trace file, and then I will be able to query it. So if we go back to, you create this as sys, you grant it to public. If you go back now to my read trace, order by line number, okay? The payload is the actual line in the trace file. So here's my trace file. I can query the server, and there's my trace file, which I've just dumped out, okay? And you can be fussy about this. Let me edit this a little bit. I'm going to pick out the trace file, which says the payload starts with the line stat percent, starts with the text stat. Because if I do that, all I get from this now, you can see here, is actually the execution plan, right? But critically, I mean, whatever else you can play around with, you can actually read your own trace file from a client PC coming in across the network into the database server. Historically, it used to be a real nuisance if you said, I need to see a trace file, I can't get at it. I can't get to the server trace directory. So if we need to look at trace files and execution plans and statistics and workloads and so forth from the server, it's available, provided your DBA has been friendly enough to say, I can create a view that looks like this, you can query this particular structure. Okay, so we've looked at the various things that help in looking at execution plans. We've pulled up the outline. That's told us what hints, what transformations might have taken place. So it makes it easier to be able to say, just don't do that bit. That helps a lot. We've looked at the predicate information. We've looked at the query block and alias stuff and made the point that you should give every query block a name. It makes it easier to sort out what's going on. You should give every table an alias and then use that alias for every column, because that expands your information that you see in the execution plan. It helps to avoid mistakes. And then critically, if you can see the query blocks, you can break out one query block at a time and say, how does Oracle operate this query block? Do I understand what's happening just with this query block? And there is this fairly simple way of interpreting a single query block. And then you can say, but the whole query links together several query blocks. And you see something like the filter, which says filter for this, for each row in this table, execute this query block. And you know what's going to happen as Oracle works through that particular part of the plan, how it pulls together perhaps the main body of the query and this query block has to execute frequently. Okay, and I've shown you various ways of getting execution plans itself. Realistically and almost inevitably, sometimes the only thing you can do is say, I've got to run on production. I've got to enable something on production so I can pull the real query with real bind variables out of production and see what really happened on that occasion when it went bad. And I've shown you that new strategy for enabling SQL trace, which can then be done system-wide, perhaps just switched on and left for 5 minutes and then switched off again, so that you can find real executions with real workloads and real bind variables. Okay, and at that point, I think I will wrap it up. And if anyone does want to ask a question, there's a couple of minutes left to do so.
Oh, okay, Jonathan, thank you very much for your presentation. No, at the moment, it seems that we have no additional questions that there are in the chat. There are in the chat no additional questions. So just a little thing I want to ask you, if you can show us again your website so we can find something interesting on
okay, right. The website, it's quite, oh, hang on. Why can't I write?
Okay. Just to be
It's
sure to find
jonathanlewis.wordpress.com.
Okay,
here we go.
perfect.
There we go. That's my website. And very recently, if we come down to the side here, I've started producing a catalog of everything. So main catalog down here at the right.
Okay, perfect. This is very interesting.
And there's, yeah, I think I've got 30 different headings in this catalog, and it's taking ages to show up.
Okay.
Here we go. Right. So there's lots of topics there. I've got 1,500 pages of information here. So I've really only just started cataloging, but under each of those catalogs, there will, oh, look, there's an execution plans catalog. There's a number of block notes, the execution plan catalog. There's a few articles listed there, and there's just lots of stuff to go in, all sorts of topics. These lists will grow over time. It takes a long time to do this cataloging. I decide I want to retest it and correct it and all the rest of it. So it's taking me a long time to fill this in. But there's a lot of stuff there on the website. The catalogs are working backwards through time now.
Yeah, perfect. I can see. In fact, this is what I wanted to know about your website, because for sure it's important to find stuff to understand better what you are explaining today as. Okay, thank you very much again for your.
So can I just interrupt? Someone has popped in with a question.
Sorry, repeat please, because the connection is not.
Answer the question if there's a couple of minutes.
Yeah, okay, I can see something in
a question has just appeared on the chat. Right, okay.
Okay, I can see.
I'll read it out and then answer it, shall I? Yeah. Okay. So maybe it's out of topic, but I'd like some suggestion in order to identify the reason of cardinality misestimates. What would be a typical checklist? Well, first, Oracle guesses. That's one important thing. You saw the example with the subquery. With some examples of subquery, Oracle will say, I don't know how I can possibly guess how many employees earn more than the average. So let's just call it 5%. And you might say, well, 50% of the employees earn more than average. So if you think it's 5%, and then I go off and do some extra work with those employees, your estimate at that point in the plan is out by a factor of 10. So there are some bits where it's really difficult to tell Oracle to do the right thing. And this is why you've got some of the new features like the SQL Plan directives, and why you've got the SQL Tuning Advisor, which say, well, I will create either numeric hints or what's it called, an SQL profile, which says, actually, at this point, you should multiply the number of row estimate by 10. The second most common reason for bad estimates is because you have two, one country is Italy and the city is Rome. And Oracle's sitting there saying, well, I've got 263 countries in the world. I've got 17,000 towns, cities in the world. So if I've got one country and one city, let's multiply together these two values. So you're one city out of 853 million. But of course, everyone who's from Italy will know, and probably most of the people in the world will know, if the city is Rome and the country is Italy, that's probably Rome in Italy, and the arithmetic's wrong. Oracle said there is no connection between Italy and Rome. There is a connection. And in that case, Oracle gave us column groups, extended stats with a particular type called column groups, which if you can see something where you know that Oracle's got it wrong because there's a very strong connection between two predicates, but Oracle thinks there's no connection at all, you may find that if you create a column group which says, give me a column group, country, city, those two columns, gather stats on that column group, Oracle will then say, oh, I've got a much better idea now. I don't actually have potentially 83 million combinations. I've actually only got 1.5 million combinations. And now my estimate is going to be much closer. It'll be closer by a factor of 50 from the mistake which I was making before. So those two, I think, are probably the commonest reasons why Oracle eventually gets very, very bad cardinalities. So always be on the lookout for for column groups, and for things like, that's an obvious guess, right? The guesses that Oracle often makes, 1%, 5%, and 0.25%. Is that right? 1 in 400, yeah. 0.25%, which is 5% of 5%, okay? And those guesses often come up where you've got column equals subquery, or column greater than subquery, or column between PL SQL function value 1 and PL SQL function value 2, where Oracle says, I've got no idea what's happening here. I'm guessing. Okay.
Okay, Jonathan.